All right, people. So that area of a triangle is just up there primarily as a reminder of that formula because you need it for your homework.
Don't we need our stuff?
Yes. So welcome to quarter 3, to where I'm not going to baby you anymore. And I don't think I've really babied you much this year at all. But the work that was assigned for last week, all week, turn it in. Okay, I'm not putting it all up there because you guys should have it written in your plan book. I put it up there every day for you. You should have it organized in your binder, so turn it all in. Once it goes into map, and this is a bad way to operate, I see some people then writing it down off of map and trying to catch up because they didn't have their assignments written down in their plan book. That's a poor decision. Stick with us. So on that note, any questions from the homework that we've been having? All of the homework for the week is up there now, so if you want to work ahead, you can, and that's a good plan. Tomorrow's is just do at least 6 of them, so you can see the little parentheses next to the assignment over there. The homework's like 11 problems, but I want you to pick whatever 6 you think you should do. Hey, I'm going to repeat that. I want you to pick whatever 6 you think you should do for the benefit of the practice. So you look at it and you're like, that's easy. Don't do it. Skip it. Practice the stuff that you need practice on. Yeah. Always. And there's extra problems too, like checkpoints and stuff. You can always find more work to do. There's a parent guide to these classes, and it's not an appropriate name, but that has extra problems to reinforce stuff. It's like if a parent at home wanted to work with their kid, but you guys could just do it on your own. I might throw that in Schoology. All of them from last week. And a lot of you have done this, and I'll give you a second to do it. Your test that we went over, notice Ava's follow-up, her test, attached in the bin. I'm showing that you did what you're supposed to.
But I'm not progressing. Now I already know.
No, you gotta not finish.
Oh yeah, I gotta not finish too.
So, that's due today as well. Your Chapter 5 mastery with the follow-up, but some of you have already turned it in. Some of you turned it in last week, but you got it done during AO. So, turn that in by the end of today. Right, AO extension, I'm cleaning that out at the end of the day. Take it home with me. So if you don't have algebra tiles, you're not paying attention, so get algebra tiles. Notice how it says it in bold text, underlined. Algebra tiles. Alright, so my brother-in-law, who was actually just texting me twice trying to figure out our vacation down there, is an accountant, and he works, well, yeah, still works, but used to work for Maine Medical, which is this big old hospital. And when I would talk to him about their accounting, he would tell me about their rounding errors. At the end of a fiscal year, which is the year of your finances, which you can set whenever you want, he said due to rounding, they would end up with over $1 million in error. Like their accounts were off by $1 million, and that was okay. Because they have so many transactions a year. Imagine if every transaction has to be rounded, like up or down by a penny, and you have millions and millions and millions. Think about medical companies. They bill you for every single item. The Q-tips that are in your room. Like, you are billed for everything. So, rounding doesn't seem like a big deal, but then when you multiply stuff by giant numbers, it gets bigger, turns into a larger deal. So, like we've been saying, we're working with small numbers now, but the skills we're building are leading to working with those really big numbers. So, we're going to dive in, but kind of remember that theme or idea as we start to get further into the course. Chen's sister made a riddle for him to solve just like yesterday's, right? So I'm thinking of a number. Okay, not just like yesterday's. Yesterday was like mind-blowing magic because we all got 5. But I'm thinking of a number. If you add 2 to the number and triple it, you get 9. So let's see how good we are at these skills. I want you guys to see if you can write that down. And if you first want to build an equation map for it, we're Remember, I didn't give this out as a resource page, but if you imagine the equation mat, I apparently need to reset my ink. Actually, I need to adjust my projector really quick. So, Aiden, I'm going to ask you to move your computer. But remember, the equation mat has the equals in the middle. So you have your left side, right side, just the equals down the middle. You can build it with algebra tiles if you want. An unknown number, 2 added to it, and then you triple it, you get 9. Okay, see if you can figure out what that number is. Well, for just a second, so I can adjust my projector. Sorry, I was cleaning the filter this morning and never reset it. Do as I say, not as I do. And now it'll just stop shaking. Thank you. Here, hold on. Let me wipe that off. That Clorox wipes.
How do you go to the toolbars again?
Blue text top left says hide toolbars. What would we use to represent our unknown number? X. So you have an X tile. What would we use to add 2 to it? 2 squares. And then, how do we show that we're going to triple that quantity?
You do that 9 times.
Yeah, you do that 3 times, right, to triple it?
Oh, it said you did.
You get 9. So the other side results with 9. Right, we end up getting 9. So if we try to build this, it's going to be our X that we don't know. And you guys said, I got to readjust this, 2 more, and we build it 3 times.
Wait, we did this on our homework last night.
I know. How amazing.
Wait,
It all connects.
but I like the way that I did my like thingy rubbers might not make sense.
It probably will. I've seen most ways that you can do this stuff.
Okay.
So you said an X and 2, and you said build that 3 times. Right. Smart Ink, can you just please work for me for like 1 day?
Marty did not like math,
And my board doesn't want me to do that. It is. By the way, when you're in the CPM tool, if you click on background, you can get to our equation mats. So right now we're using equation mat 1. So if I wanted that background, I can apply it. So that equals 9, right? So if I bump out, oh, they didn't give me a 5 tile, so. What could I do with my 9 to make it kind of easier for this situation, Sky?
Never mind.
I'm just gonna kind of like make a pile here, right?
You're making a question mark.
Wait, 1, 2, 3, 4, 5, 6. Too many.
My name's not Brenda.
What could I do with my 9 tiles to make it easier to figure out what X is? You? We can what with each square? I'm in a square, alright. Okay, there's my 9.
You can separate it into 3 even.
Ah, because I have 3 groups over there. If I make this 3 groups over here, then I can relate that one of the groups must be equal to 3. Now on our graph paper, let's go ahead and write out what we just did. We had 3x. Wait, no we didn't. We had x, right, plus 2, and then we tripled it. Please write that like that. Yeah, on my desk there by the pencils and everything.
Oh.
we set that equal to 9. Now there's a reason we're going to write it like this. We're describing 3 identical groups. 3 groups of that unknown and that 2. When we go to do that math on both sides, now where yesterday I told you couldn't divide first, well not couldn't, but it kind of made things complicated. This left side, from your eyes but don't write it, is actually, sorry, not 9x. It's 3x plus 6, right? If I distribute and if I rewrite it just as what I have. But if I leave it like this, I can just say, okay, entire left side, divide by 3, which would be the same as if I had it written like this. But here's that part where I said it gets complicated. I have to divide both pieces. So 3x divided by 3 gives me 1x. 6 divided by 3 gives me 2, which is what I had from inside the parentheses. Right? So if I just leave it written like this, we divide by 3 and these reduce out to 1. Now you can write it either way, but when you divide, you got to divide by everything. This is one thing, because there's no addition or subtraction. That is one thing, because the addition and subtraction is in the parentheses. That's one term. Remember, that's one thing together. We divide by 3 and it reduces out. So we get x plus 2 equals 3. Sorry, my 1x looks a little weird. Smart words trying to catch up this morning. So we took the 3 groups of x plus 2, and we looked at only one group. Mathematically, what we did was divide by 3. Right? Because we, instead of looking at 3 groups, we're only going to look at one group. So we divided by 3, and one group is just x plus 2. That one group must be 3. So x here must be 1. And we would get there by minus 2, minus 2. Questions on that? So I wanted us to all have algebra tiles in case you want to visualize these things as we go. You don't have to use them. If you're already comfortable writing these things out and showing that work on your paper, you don't have to use the algebra tiles. I just wanted us to all have them. Questions on our process here? How we're allowed to divide by 3 first. You don't have to, but you're allowed to.
So basically what you did was you did 3x plus 2, solved that for 3x.
So it wasn't 3x plus 2, be careful. It was 3 groups of x plus 2. So what we actually had was 3x plus 6. But I chopped my entire mat into 3 pieces and just looked at one piece, which was x plus 2. So I chop it and divide by 3. So if we come back and look at this one, solve that in any method you would like. We have 4 groups of x plus 3. So if you want to build it on your algebra mat, and I'm about to, you have 4 groups of x plus 3. If you really like doing it on the computer, you can grab a Chromebook, but at this point it kind of takes longer. Now, if you are doing this problem, 61. Yep. One thing you could do first here is to distribute on both sides. There are multiple ways to solve this, and we're probably going to go over both. I wonder if I can copy paste. Aha!
Wow. So blue is fuzzy, right?
Mm-hmm. Why do you not know what you're doing?
No, it was about the out where she was putting the out.
We are going to want to write this out. So if you haven't written it out, please get to that point at some point. I'm going to show one option and go back and do it all over again, so ignore me for a minute. You should be good at that. You're in middle school.
Wow.
What? I'm trying to make a joke.
He's not wrong. He's not wrong.
What? Does that mean? Yeah. Oh, sorry.
Verify your answer with someone you haven't talked with yet. Like you should have an answer. Talk with somebody. Verify your answer. I feel like some people went to verify and they found out not everyone was done.
X equals
If we distribute first, we get 4x plus 12, which is also, if I just look at the mat that I made, I have 4 x's and 12 ones. Yay, observation. So then, Brendan, what would I do if I was following the process we've been doing? We would minus 12 on both sides to get rid of that constant value. So I need to realign my smartboard again. So then, if we do what we've been doing, Sophia, what would we do next?
So after that, what you would do is you would add negative 12.
So remember when I told you guys algebra tiles are tough because you play with them and you're back to playing with them? Brendan just told me this step. What do I do here? There we go. Try to stay with me. If you've not written this out on your paper, please do so. X becomes negative 1.
what?
The only way... That's my smartboard being broken. The only way that this situation can be true is if X is worth a negative 1.
Why does that work again?
Because think about it. Right now, the left side, like if we don't move any tiles, if we just look at the picture when we started, we have more 1s on the left hand than we have on the right hand. Right, we only have 8 1s on the right hand side. Here, look at this. Think about why does this make sense? Because then we're going to talk about checking our solution, and then we're going to do this a whole different way. My right side has 8, my left side has 12. My left side has more right now. Without the x's, my left side has more. The only way these could be equal is if the x, the 4 x's, reduce the amount that's on the left side. So this makes sense. X is negative 1. Now we could check this by coming back to our distribution and saying, okay, if I say X is negative 1, then plug it in. And you did this on your homework, if you did your homework. not funny, really. That'd be 4 times negative 1 plus 12. Well, 4 times negative 1 is negative 4. Negative 4 plus 12, does that equal 8?
Yeah.
Negative
Oh,
4
wait.
plus
That's
12
showing.
works.
Bro, you can tell me.
Now, if we go back to the beginning,
No, it doesn't count with him. No, it doesn't.
we go back to the beginning. Can anyone tell me a different way that we could start? Like different than what we've been doing. I have 4 groups of x plus 3. Aiden? No, that's what we just did. I want different.
Well, what? There is no different way.
Look at the math. Forget about the algebra. Look at the algebra math. What could I do to the math kind of visually to make it easier?
Oh, you can take away.
I kind of already did it.
You can take away. I was gonna say you can take away 3, but that'd be wrong.
We could take away 3. Like, we could physically take away 3 from both sides. But that's not going to make this, like, the easiest
I
way.
know, that's why I was like.
What we could do to make this easier is split it up. But if I split my mat into 4 pieces, that mathematically is this division by 4, and we would then get x plus 3, a group, right? One of the groups of x plus 3 equals what? 2. Well, what number has to add with 3 to make 2? All of a sudden, we've jumped to the solution. Because we could then take away 3, and x equals negative 1.
I don't like him.
This, instead of distributing,
Excuse the interruption. Could I please have Katie show up to the office? Katie?
so when your brain says, we could distribute this, your brain should also say, wait a minute, we could take the easier route of not distributing, divide first. Does this make sense, / are there any questions?
Wait.
Always positive.
The 8 divided by 4 is always 4 divided by 4 equals 1, which says 1x.
Now 4 divided by 4 does equal 1, but what we did previously was negative 4 divided by 4. The last, when we solved it through the other way. Here we subtracted 3 to get to the. So here, yeah, we make one group of x plus 3.
Oh.
So this would turn into 1, which doesn't do anything, right?
Are we allowed to use that on our homework?
Oh yeah, you can use any method that works for you. So, and if your parents show you a different method, there's a lot of ways to do algebra. Because remember, guys, you can do anything you want as long as you follow those few rules. Where? Oh, I dragged the lesson up here. Does checking your solution make sense? Like when we plug it back in, we make the x, and you had situations that said like, evaluate for when x equals this or when x equals that. That's a fancy way of saying solve. All right. So exactly to the point of there being multiple ways to solve this work, Madison and Kelly are confused. Madison, do you have a friend named Kelly? Your Aunt Kelly. There we go. So Madison's talking with her Aunt Kelly. They both start out with 2x minus 7 equals negative 2x plus 1. Go ahead and write that out, please. 2x minus 7 equals negative 2x plus 1. Now, Kelly got 2 for her solution, and Madison got negative 1.
Wait, why did we switch it?
Madison, so this equation, right, different stuff on left and right, they both solved it. Kelly got 2, Madison got negative 1. I want you with your team to determine which one of them is right and be able to back it up with evidence, like justification, like stuff written down. So they think, well, we could plug in our numbers and figure out if we got it right. Agreed. You can plug in the value that they think it is and figure out if it's right. You could also solve it on your own. If you would rather say, forget Madison, forget Kelly, I'm going to try this on my own and see if I get an answer that matches one of theirs. Okay? Dive into this. I'll give you at least 3 minutes. Let's figure out who is correct here. You're either substituting to test or you're solving it out on your own. And then have a conversation about it.
You don't know what you're doing. Shh. So therefore,
We're able to help each other, not just shush and stuff like that.
I could wait. Did I shush you? Yeah. Oh, she shushed me a lot.
Yep, it is a negative 2x. Sorry, if I was being particular, this would be in parentheses. So Kevin kind of called me out in a polite way. I don't like subtraction, so instead of that, I could do plus negative 7. And when I start with a negative, I like to put it, well, regardless of when I use the negative, I like to put it in parentheses. So that's a negative 7, or you can think of it as minus 7, and negative 2x. Why is it confusing? So first I'll write out what they start with. Just write out the 2x minus 7. Or 2x plus negative 7. Hey guys, I need to make a request. So I made this request with 3B, and they're doing really well. And then no offense, but you guys come in here and trash it. These books we talked about when we started doing motor books, we're all lined up 52 to 63, like just bottom sticking out. People keep, which I understand why you're doing this, people keep trying to put it away like this, which doesn't help me check really quickly, do we have all the books? So I need, when you put your stuff away, this is going to work, and we're going to use loaner books so you don't have to bring yours. Please, at the end of class, make sure they're right, and if you're one of the last people putting the books back, just fix anything that needs to fix. You know you're not in a big rush, right? You're not in a big rush to get to your next class. So please do me that favor so we can keep using loaner books. Because they all fit, and they fit really nicely. Now, the Math 2 class, those are their actual books, so if they screw it up, they just owe me $77.
What?
Yeah, the books are worth $77 if one of them loses their book. But that set right there, our books that we're using, those have been recollected, and those are like classroom loaner books now. But if they get lost, then we'll have to disperse the fee to everybody, so it'll be like $1 per kid.
Oh, that's easy.
Well, but we don't want to do that. I'd rather you spend that $1 on like candy or pizza or something.
How do you get candy with $1?
$1 can buy you.
What?
$1 is easy. All right, who's got an answer that will share it with me and their evidence of how? All right, well, especially since you both have your hands up. Gentlemen, what'd you get?
2.
So, group up here got 2.
No, that's correct.
Do we agree or disagree? Agree?
Agree.
How'd you guys do it?
I plus 7. Then,
Plus.
yeah.
Yeah, I agree.
I didn't agree.
And then I plus 2x, and then I divide by 4.
Plus 7, so we had 2x equal to negative 2x plus 8. Sorry, my work isn't very nice here because I'm writing over top of stuff. And then you said you added 2x to both sides, so you end up with 4x equals 8. And once we're at that point, we can just kind of figure it out. Now, I totally agree with you guys. But when I move on and I look at what it said, I'll give you plenty of time to solve it. Even if you need help, stick up a hand and get me help you. But I need you to stop making noises that interrupt my teaching. Hey, so I need you to stop interrupting my teaching, please. Kelly ended up with negative 3 equals negative 3. anyone not just solve the equation? I know we're getting good at solving the equation, but did anyone get to negative 3 equals negative 3? Greta? How'd she do it? What did she do? How do you get to negative 3 equals negative 3? Well, what did you do first? Like, what did you write down? Oh, so you're doing them. So Greta and Kelly did this right here. So if you want to write this down, awesome. You don't have to. This is what we call, and you might want to write down this word, substitution, which you should know from your career of your teachers getting sick occasionally. When you replace something with something else, you're substituting. You might substitute meat for tofu or whatever, like if you're a vegetarian. In math, we substitute a number for a thing we don't know. Hopefully there's no like unknowns in what you're eating. But when they said x is 2, Kelly said, I'm going to substitute x is 2, so anywhere there was an x, she plugged in a 2. So what's 2 times 2?
4.
4 minus 7, negative 3. Negative 2 times 2, negative 4 plus 1 brings me back up 1, negative 3.
Oh.
We're at negative 4, come up by 1.
Okay, wait, I thought you said just 4.
Because remember that this is kind of far away, but the negative 2 times 2, that negative 1. So that makes that product, the multiplication, negative.
So then we'll just do negative 2 times 2 and then plus 1.
It depends on what route you want to go, but that's one way we can go. That's how Kelly got negative 3 equals negative 3.
Oh, I thought Madison was right.
So when Madison solved, what is 2 times negative 1? Negative 2. Go down 7 more. Negative 9, right? From negative 2 down 7. And then what's negative 2 times negative 1?
Negative 2.
Ooh, positive. Careful. Negative times negative. So positive plus 1, 3. Is this true? No. So obviously this isn't our Madison, because this answer is not right. So our Madison would have the right answer. So this is how we see. And guys, this is what I'm going to be looking for on your mastery in your eyes. There will be a question that says you must show a check process, which is this. Substituting in. If you get to something that's not true, this isn't true. That wasn't your X. Sorry. Please come again. Questions? Questions? Yes.
I think I did something wrong because when I did the way that you just showed us, with like dividing the thing, I got negative 4.
You check your math. I can come back there in a second and check your math
So
for
you're
you.
supposed to end up with negative 3, right?
Well, if you substitute, we should end up with negative 3 equals negative
So
3.
you substitute x.
Anytime we substitute and it's right, we get a number equal to itself. We get a true statement. Let's do another one. So, here in 63, if we go to verify our solution, we said that x is negative 1. On your paper, show a verification process. Even if you did it when we were there, or if you did it when we were up there, you can look at 64. That's some more practice we're going to tackle. But show a verification process for 63. I'm going to give you like a 20-second head start, and then I'm going to write it up here. Show that check process.
But we're doing that while we're doing Wait, what group?
Class, our group,
Oh,
our community of Math 7. Some people, when they're starting out, like to highlight what they substituted. So if you want to grab a highlighter, and in your problem where you plug it in, go ahead and show that that number's new in your problem because it took the place of your variable. So then I can actually do the math now. What's -1 plus 3?
2.
2, and then 4 times 2 equals 8. Is this true?
Oh,
Yes.
wait. So you just have to substitute that so you can get the answer.
Well, so we can verify that what we use is right.
I am so. I need to go.
Well, wait, will you explain that again?
Yes, thank you very much. I appreciate questions like that.
Thank you so much.
We solved a problem, right, earlier. We got a solution. X is -1. To check if we're right, because we're human, we make mistakes, you plug it in wherever, any place that you see an X. We only have one.
Oh,
See.
there we go. Okay.
Light bulb? Good. Anybody else?
Wait, but what? Wait.
Ask for seconds if you're still hungry.
If because then one gets
Well, for math?
Oh.
All right. If we look at 64, a little bit of problem solving real quick. Dive into that and try to effectively. You can build it if you want, but you don't have to. Remember, first combine like terms. I'm going to write it on the board here in just a second. You could distribute if you want, or you have other options.
That was a long problem.
Not really. It is right now. We can make it a whole lot easier. I know, because my boots are clunky. I'm not used to wearing boots to teach up here. I'm normally in like sneakers or whatever. Because it's raining.
Yeah, Natalie.
Wait, those are called clocks.
No, I said my boots are clunky.
Those are boots.
If we want to distribute first, which here is probably the best idea, draw your arrows.
Wait, what is X equal?
We don't know.
We don't know.
That's what we're trying to figure out.
And we
This is a new problem.
Oh, so the
New problem.
No, we're not substituting it because it says 10.
We're not checking right now. We're trying to solve.
Yeah, we're
Then
not-
we'll check. First arrow gives me 4x. Next arrow gives me
5.
Not yet.
4. I'm sorry.
You're ahead of me.
We're multiplying.
Yeah, you've already added the.
Yeah, I'm sorry.
We will get 5. You just gotta hang on for a second.
Wait, are we doing PEMDAS?
Always. When are we? We always have to do PEMDAS. Order of operations controls everything.
Wait, why is that funny, Mr. Hudson?
It-
Isaac laughs at everything.
Why is
I think it's how you asked it, but I will say I find it.
Okay,
I don't
wait,
know about
I know why
funny,
it's funny is.
but like we always have to. Like asking that. That's kind of like saying, "Hey, are you breathing?" Yeah, we're using PEMDAS because it's math.
Oh, it's PEMDAS? Oh, I
Yeah,
thought it was
PEMDAS.
PEMDAS.
I mean, if you want to pronounce it a little bit more German, sure.
PEMDAS.
What other like terms can I combine? Aviva? Yeah, the -x and the 4x, because I already combined these and got my 5. So 4x and -x,
So 3x.
I get 3x.
Oh, I'm on the wrong thing.
We are on A of 64. We're on A of 64.
Wait, how does it equal 10 plus
Now, again in your head, check variables, constants. Right? Variable term, constant term, constant term, variable term. We have 4 options here. I encourage you guys to do your homework together. But you'll realize you think differently than some of your friends. I could subtract 3x. I could subtract 5. I could subtract 10. I could subtract x. Always on both sides. What's the best option here for easy? Like easy option. Did I do that?
Either 5 or X.
Yeah, subtract the smaller stuff, right? Get rid of the smaller things. So we want to subtract. I like to deal with variables first, just personal preference. So I'm going to subtract an X since that was one of the options you gave me. Then, Ava,
Yeah.
if I gave you a pop quiz right now, like I'm planning to do Friday, will you be able to show me mastery of this?
Thanks for giving us a heads up.
Yeah, Mr. Hudson.
She just shook her head
Well,
and said
so laying across the table right now is probably not the best thing to do when
No,
we're
I
reviewing how to
understand
solve
what we're
this.
doing.
Do you have this on your paper?
Yes.
No,
no.
you don't. So I need to see you after class because my extension for this comical sort of thing is we're past it. So let's have a chat. I'm here now. We've pushed the variable off the right side by subtracting it because we're allowed to do anything we want. Now we want to, anybody? Subtract 5 because you got to push that constant. We get 2x equals. Yeah, this one's not as easy. After we divide, we're going to get that x equals, or leave it as an improper. You can write that as your answer. Or you can write 2.5, or put both to cover your bases. It's a baseball term, cover your bases. Any questions? Please put away your algebra tiles or anything else that you got out, because we're doing different stuff in the other classes. Thank you guys very much.